So, what we have here is the application of differential equation. In here, we can apply what we have learned so far in differential equations. In the first problem, we have a tank contains 200 gallons of brine in which 20 pounds of salt are dissolved. Brine containing 1/4 pound of salt per gallon runs into the tank at the rate of 2 gallons per minute. The mixture, kept uniform by stirring, runs out at the same rate. What is the limiting value approached by the amount of salt in the tank as T increases indefinitely? And when, if ever, will the amount of salt in a solution be 20 pounds? So here we have a 200 gallon of brine. Then 200 gallon, which is our V sub O, is 200 gallon, and in which 20 pounds of salt, so it's a R X sub O. So 20 pounds of salt are dissolved. So, and brine containing 1/4 of salt per gallon runs into the tank. So that is our concentration CI is 1/4 pound. Runs into the tank at the rate, which is our R sub I, of 2 gallons per minute. Then the mixture, kept uniform by stirring, runs out at the same rate. So keep in mind runs out at the same rate. So our R sub O is the same as our R sub I, which is 2 gallons per minute. And as of course, C sub O is not given, but we have the equation of X over V, where we can find V by the use of formula by the use of formula V is equal to V sub O plus R sub I minus R sub O times T. So our V sub O is 200 gallons. So 200 plus R sub I is 2. Same with R sub O is 2 times T. So V is equal to, this is 0, so 200. So our V is 200. So X over 200. So we have that. So with our formula of dx over dt is equal to R sub I times C sub I minus R sub O times C sub O. That is our formula. So dx over dt, oh my god, dt is equal to R sub I, which is 2, times C sub I, which is 1/4, minus R sub O is same with R sub I, so 2 times, we have C of O is equal to X over 200. So X, okay, dobat na guro. Ay naman. So R C sub O is X over 200. Then we can combine dx dt is equal to 2 times 1/4 is 1/2 minus 2 times x over 200 is 2x over 200. Then You can further simplify. Purot ng ink. Dx over dt is equal to 1/2. 2 over 200 is 100. So x over 100. Then we can separate it. This is a separable differential equation, so we can separate it by multiplying dt. So we can cancel. We have dx is equal to 1/2 minus x over 100 dt. Then we can divide both sides by 1/2 over x over 100. So we can get dx over 1/2 minus x over 100 is equal to dt. Then we can integrate both sides. So we let u is equal to 1/2 minus x over 100. Then du, this is in terms of dx. So dx, du is integral of x is 1, integral of 1/2 is 0. So our du is 1, integral of x is 1, so 1 over 100 dx. dx is du over negative 1 or 100, then or negative du over 100. So our equation dx, so just 1 over u du over negative 100. Then so 1 times negative 100 is negative 100 over u. Then we can take out 100, integral of 1 over u du, which the integral of 1 over u is ln u. So negative 100 times ln, and our u is 1/2 minus x over 100 plus c. Then plus c, we still have dt, integral of dt, which is the integral of dt is t plus c. So can then divide both sides by 100. So negative 100 ln of 1/2 minus x over 100 is equal to t plus c 100. Negative 100. So you can cancel. We'll have ln of 1/2 x over 100 is equal to t, negative t over 100 plus c. Then we can exponentiate to cancel ln. So we'll have, cancel that. We'll have 1/2 minus x over 100 e raised to negative t plus c over 100. Then subtract both sides by 1/2. Not negative, but 1/2. Oh, yeah, negative. Yeah, negative. Subtract both sides by 1/2, so we can cancel this. We have negative x over 100 is equal to e raised to negative t plus c over 100 minus 1/2. And then we can multiply both sides by negative 100. So we'll get, cancel this, x becomes positive because negative times negative. Then we'll have 100 times e raised to negative t plus c over 100 minus 1/2. Then simplify, we get x is equal to 50 minus 50 e raised to negative 2t over 100 minus c, right? Yeah, minus c. So we'll get x is equal to 50 minus 50. Then we have negative 2. So we'll have negative 2 divided 100 is negative 0.02. And our problem, which t increases indefinitely, so it increases infinitely, so negative 0.02 times infinity minus c, which I will still have e, so e raised to infinity is 0, so we have x is equal to 50 minus 50 times 0, which will have x is equal to 50 pounds in our first problem. So here, what is the limiting value? So our limiting value is x is equal to 50 pounds. As the tank increases t in the tank as t increases indefinitely. So our x is 50. So to solve for the other problem, which is when if ever will the amount of salt in the solution be 20 pounds. So we are going to solve for t in this problem. So we'll have x is equal to negative 100. Oh wait, you can just use this equation. X is equal to 50 minus 50 e raised to negative 0.02 plus minus, wait, we still have t, so minus c. Then we can, so at first we have a tank contains 200 gallons of brine in which 20 pounds of salt are dissolved. So our x is 20 pounds. So we substitute 20. So we'll get 20 is equal to 50 minus 50 e raised to negative 0.02 t minus c. Then we can subtract both sides by 50, negative 50. So we'll get negative 30 is equal to negative 50 e raised to negative 0.02 t minus c. Then we can divide both sides by 50. 50, negative 50, negative 50. So cancel, we get 3 over 5 is equal to e raised to negative 0.02 t minus c. What we can do now is we will put ln and ln. So we can cancel ln of e, ln and e. So we'll have ln 3 over 5 is equal to negative 0.02 t minus c. Then we can separate t, which is equal, we can separate t, so which is, okay, not working again, which is equal to t is equal to negative 1 over 0.02 times ln of 3 over 25 minus C over 0.02. So RT is non-negative. So there is no T for when X is equal to 20 pounds. And that is it for our answer. So in our problem number 2, what if the tank initially contains 100 gallons? 100 gallons of brine. Wait. So what if the tank contains 100 gallon? So it's our V of brine, in which 25 pounds, so which is our X, is equal to 25 pounds of gallon are dissolved. And if brine containing 1 pound of salt per gallon runs into the tank. So we're gonna work with what we have in the previous example, which our C of I now is 1 pound of salt per gallon, and our R sub I is still 2 gallons per minute. Wait, gallons per minute, which is the same for R sub O. 2 gals per minute. Then RC sub O, which is now different. So RV is equal to 100. 2 minus 2 times T. V is equal to 100. So RC sub O is X over 100. Then, by the use of the formula, dx over dt is equal to R sub I, which is 2, times C sub I, which is 1, minus R sub O is 2 times X over 100. So this is the same as for our previous example. So we'll have 2 minus 2x over 100, which can be written 2 over 100 is 50, so x over 50. Dx over dt, the same as before, we can separate it, which will now equal to dx over 2 minus x over 50 is equal to dt. Then we can integrate. So let u as 2 minus x over 50. So du is negative. Du is negative 50. By then we can integrate it. So we can take out negative 50. 1 over u du, which is negative 50 ln of u, which is 2 minus x over 50, is equal to the antiderivative of dt is t, so t plus t. And we can divide both sides by negative 50. Then we can have ln of 2 minus x over 50 is equal to negative t plus c over 50. Then we can exponentiate both sides, which will get us to ln of, so exponentiate get us to ln of 2 minus x over 50 is equal to negative e raised to negative, can take out c, so 2t over 50 minus c. Then we exponentiated this, so our ln cancels. There's no more ln here, so we can subtract negative 2 on both sides. We can cancel 2, which will have x over 50 is equal to e raised to negative 2t over 50 minus c minus is minus 2. Then we can multiply both sides by negative 50. So cancel. So our x is equal to negative 50 times e raised to negative 2t over 50 minus c minus 2. Then to simplify, we get x is equal to negative 50. So negative 50 times negative 2 is 100. Then negative 50 times e raised to is negative 50, so minus e raised to negative 2 over 50 is 0.04 t minus c. Then anything raised to infinity, if e raised to infinity, we can equal e to 0. So x is equal to 100 minus 50 times 0. So our x is 100 pounds. Now to solve for t, which will be, we can use this equation. We can have x is equal to negative, x is equal to 100 minus 50 e raised to negative 0.04 t minus c. So our x is 25. So substitute x is 25 is equal to 100 minus 50 e raised to negative 0.04 t minus c. We can subtract both sides by negative 100. Or add both sides by negative 100. So if we add, we get negative 75. And if we 75, then if we add negative 100, we can cancel out 100. So we'll get negative 50 e raised to negative 0.04 t minus c. And after that, we can divide both sides by negative 50, which will we can get by we can get 3 halves if we divide negative 75 over negative 50. So 3 halves is equal to cancel 50, then we cancel signs, then we can have e raised to negative 0.04 t minus c. So to get rid of e, we can use ln. So cancel. So ln 3 halves is equal to negative 0.04 t minus c. And then we can simplify. So t is equal to negative 1 over 0.04 times ln of 3 halves minus c over 0.04. So again, t is non-negative, so there is no time for when x is equal to 25 pounds. So it is still 25 pounds.